Greetings. We will be continuing on our Physics Ignition series. In the previous class, we talked about units and measurements, where we talked about the different types of units and the instruments used for measurement. So today, we will be advancing to a very important topic called motion. Greetings, future rockstars, and welcome to Josh White Academy, where we fuel your success with experience-backed strategies and science-based tutorials. If you are new to this channel, I am your host, Josh White, and it's my mission to help you crush high school with confidence and clarity. So please do well to subscribe, turn on the notification. Let's get started. In today's class, we will be dividing the lesson into 4 different sections. In the first section, we will talk about the concept of motion. Secondly, we will talk about the types of motion. Thirdly, we will talk about the equations of motion. And finally, we will be using those equations to crush UTME questions. Let's get to class. Motion is a very important physical concept. It's even one of the characteristics of life. But not only living things move. The change of position or location from a point to another point is termed motion. And the study of motion is called kinematics. And we must know that a body will remain at rest, or if it is in motion, will continue in that same uniform motion unless there is an influence of an external force. That means for a body to be in motion, there must be an influencer, and that influencer is termed force, which we will deal with appropriately in another different class. So, we will be talking about the types of motion. The first type of motion, we call it the translational motion. Some may call it linear motion. This is the type of motion where a body moves from a particular point to another particular point, most times in a straight line. Like, for instance, the movement of a train in a railway, or the movement of a car from a particular position to another different position. These are translational motion or linear motion. Secondly, we have circular motion. This is the movement of a body round a circular path or orbit, like the way the Earth and other planets rotate round their axis or revolve round the sun in a circular path. Or even the movement of our fans, or the movement of the wheel of our vehicles. They follow a circular motion. Thirdly, we have oscillatory. We can also call this vibratory motion. It's a type of motion where a body moves to and fro like that of a simple pendulum. So they are oscillatory motion, or when you strike a string or a drum skin, it vibrates around a fixed point. So that's oscillatory or vibratory motion. Number 4, we have the random motion, where a body moves in a zigzag, non-directional, scattered manner, like the movement of smoke in air, the movement of pollen grain tossed by the water tide. or the movement of dust particle in the air, they follow a random motion as explained by Brownian motion. We also have what I term relative motion. Relative motion is a type of motion where a body moves in relation to another body. Like for instance, I am inside a train that is moving forward and I am moving backward. Or I'm inside a train that is moving forward and I'm moving forward. You can see questions like that in UTME. Let's say for instance, a vehicle is moving towards this direction at 50 meters per second. And a man inside the vehicle is moving in opposite direction, let's say 10 meters per second. How will you find the resultant velocity? If they are moving in opposite direction, you subtract it. So the relative motion now will be 50 minus 10, which will give you 40 meters per second. If they are moving in opposite direction, that means the person who is moving backward has a lower velocity compared to the moving vehicle. And if the vehicle is moving, let's say 50 meters per second, and the person is moving in the same line, in the same direction, in 10 meters per second, the relative motion is the sum of the both vectors, which is 50 plus 10, which will give you a 60 meters per second. That means the person moving in a moving vehicle has higher velocity than the vehicle itself. So that's relative motion. The motion of a body in relation to another different body. So these are important types of motion. So now let's talk about the equations of motion. I will be sharing with you 4 of them. The first one is V is equals to U plus AT. The second one is F is equals to UT plus 1 over 2 AT squared. The third one is V squared is equals to U squared plus 2AX. And fourthly, F is equals to U plus V all over 2 close bracket C. So these are the 4 equations of motion you need to crush physics motion. So our V is final velocity, our U is initial velocity, our A is acceleration due to gravity, our S is distance covered, our T is time taken. So this is all you need to know regarding equations of motion. You must know that based on the nature of the question, this plus here can be a negative. So it can be plus or minus based on the kind of question. And our distance here can be height if it has to do with a body under gravity or a body in a particular height. Our x here can be changed to h, and our a here can be changed to g, gravity. So let's move to the important part of this class today. Let's go and crush JAMB questions. Come with me. The first question. A palm fruit dropped to the ground from the top of a tree, 45 meters tall. How long does it take to reach the ground? Remember from the previous video of the 7 steps I showed you on how you can use to solve any physics problem. So we'll be applying it to solve these questions. Remember, the first thing I say, identify the topic. So we will not be needing that one because we already know our topic is motion. The next thing to do is to understand the question. Now, a palm tree dropped to the ground. If a palm fruit dropped to the ground, that means it was first at a potential level. At that level, it was at rest. That means our initial velocity is what? 0. And from this question, our height is 45 meters. And we are asked how long. How long means we are finding what? Time. We are giving G as 10 meters per second. So now, our data. We know that our U is 0. Our height or distance is 45 meters. Our acceleration due to gravity is 10 meters per second square. And our time is what we are looking for. So now, the next thing to do is, among this formula bank in our equation of motion, which formula best suits our listed data? So, in our data, we have height, we have gravity, and we have time. Here, there is no height. It's out. Here, there is height, there is gravity, that's acceleration, and there is time. It's good. This one, there is height, but there is no time. Out. This one, there is height, but there is no gravity. So our most suitable formula is this second one, which says that height, which is S, is equals to UT plus 1 over 2 AT squared. In this case, our A is our G, as I said previously. So now, remember our U is 0, that means here will give us a 0. So H is equals to 1 over 2 AT squared. So our H is 45 is equals to 1 over 2 times 10 T squared. 2 here 1, 2 here 5. That's 45 is equals to 5 T squared. Divide both sides by 5. So our T squared is equals to 9. Square root both sides. So our T is equals to square root of 9, which is equals to 3 seconds. So our answer is what? E. To the next question. A body falls freely under gravity, G as 9.8 meters per second square, from a height of 40 meters on to the top of platform 0.8 meters above the ground. Its velocity on reaching the ground is... So now, one of the important things to take note in this question is understanding the question. This is our second principle. Understanding the question. Now look at this. We were giving G as 9.8. So we can just start putting down our data. G is 9.8. From a height of 40. Height is 40 meters. Onto the top of platform 0.8. That means the body did not fall to the ground. It fell on top of a platform, and the height of the platform is 0.8. So imagine, for instance, this is the body and this is the ground, but there was a platform here. The height from here to here is the 40 meters. The height of the platform is 0.8 meters. So the body fell to this platform. So what will be the height that the body will cover to strike this platform? It will be 40 minus 0.8. So please take note. Understanding questions is very crucial. So our height now will be 40 meters minus 0.8 meters, which will give us a 39.2 meters. Other data is velocity on reaching the ground. Remember, the velocity before the body fell will be 0. So U is 0 meter per second. Then the velocity on reaching the platform, that will be our final velocity. That's what we are looking for. Okay. Now, the next thing to do is to begin to check now the data you've brought out, which formula best suits that data. So in our question, we have gravity, we have height, and we have velocity. So let's examine our formulas. There is V, yes, there is V, but there is no height. So this one is out of it. This one, there is height, there is gravity, there is initial velocity, but they didn't give us final velocity, and they are giving us time here, but there is no time in our question. So number 2 is out of it. Number 3, there is final velocity, yes, there is initial velocity, yes, there is acceleration, and there is height. You see it? The equation 3 best suits our data. Equation 4, you see there is no gravity, so this is out. So our best suitable formula is equation 3. That's B square is equals to U square plus 2AS. Remember, our A is G and our S is H. So let's substitute now. Our B square is equals to our U is what? 0 from rest. 0. 0 square is also 0. 2 multiplied by our gravity is what? 9.8. Please take note. If you are giving gravity as 9.8, don't use it as 10. JAMB may solve using the 2 different figures, knowing that students most times have mastered the 10, so they will not follow what was given them and they will miss out in that question. So please always follow the one you are being given. But if you are not given, then you can use your 10. So AS, our S now is 39.2. Please take note, not 40. Multiplied by 39.2. So our B square is equals to 2 multiplied by 9.8 multiplied by 39.2. Our answer gives us 768.32. So the next thing is square root both sides, or if square crosses the equal to sign, it becomes square root. So V is equals to square root of 768.32. So our velocity will give us 27.7 meter per second. This is our answer. So that makes E the correct answer. That's just what you need. Know your formulas, know how to use them, understand the question you're given, and it will be very easy. The next question. A train has an initial velocity of 44 meters per second and an acceleration of minus 4 meters per second squared. Its velocity after 10 seconds is... So I can notify something from this question. Acceleration of minus 4. If an acceleration is given you in a negative sign, that means that's deceleration, that's retardation. So I think that's all, and we are being meant to find velocity. So let's get our data. Our acceleration is equals to negative 4 meters per second squared, which is simple. You can just write deceleration there. We have our initial velocity U as what? 44 meters per second. Our time is 10 seconds. And our velocity, our final velocity, is what we are looking for. So A, U, C, and V. Which of our formulas in the equation of motion best suit our data? A, U, V, and C. There is no A here out. There is no C here out. There is no V here out. A, U, V, and T. You see it. The first equation best suits our data. So let's use it. So V is equals to U plus AT. So we are looking for V. U is 44 plus A is our negative 4 multiplied by T is what? 10. You see it? So please don't make the mistake of plussing before you multiply this, because remember, in board mass, multiplication comes before addition and subtraction. So please do well to multiply this first before you sum them. So minus 4 times 10 will give you a minus 4t. You see it? So plus times minus is negative because of different signs are negative, whereas similar signs are positive. So that's 44 minus 40. This will give you a 4 meter per second. That's what? B. You see it? Simple. So let's go to the next question. So this is the next question. Please, if you've been enjoying the class thus far, please do well to click the like button there. If you've not subscribed, please do well to hit the subscribe button also. Like, share and comment. Okay. A body moving at 20 meters per second decelerates uniformly at 5 meters per second square till its speed becomes 10 meters per second. The distance covered within this period is... Now, you must take note. A body moving at this, that's our initial velocity, decelerates uniformly. Deceleration is a negative acceleration. So even though they put 5 meters per second square here, you should know that it should be negative 5 meters per second square. Please take note. Retardation or deceleration is a negative acceleration. Till its speed becomes 10 meters per second. Please take note. Speed here still means our velocity. So that's our final velocity. So we are being asked to find distance covered. So let's write our data down. Our initial velocity is 20 meters per second. Deceleration, that's our acceleration now, will be a negative 5 meters per second square. The final velocity, which is our final speed, 10 meters per second. So we are being asked to find distance. So we have U, we have V, we have A, and we have S. So which formula here carries our data? UAVS. UAV, no S, out. U, no V, out. UAVS. Correct. U, no A, out. So our appropriate, the best suitable formula is what? Our third equation of motion. That V square is equals to U square plus 2AS. But in this case, since we are having a negative acceleration, this our plus will become minus. But I will show you how. But leave it still as plus. So let's substitute our data. Our V is 10 square is equals to U 20 square plus 2. Our A now is a negative 5. That's minus 5S. You see it? So let's simplify. 10 square is 100. 20 square is 400. Plus minus 5 times S is minus 5S. Minus 5S times 2 is what? Minus 10S. So plus times minus will give you what? A minus. Remember I said different sign, plus times minus or minus times plus will always give you a negative sign. Whereas the same sign, plus times plus or minus times minus will always give you a positive sign. So this will become 100 is equals to 400 minus 10S. So let's collect like terms. 400 goes to this other side. It becomes 100 minus 400 is equals to minus 10S. This will give you minus 300 is equals to minus 10S. Divide both sides by the coefficient of S, which is minus 10 minus 10. So our distance is equals to 30 meters. So our answer is what? A. So let's take one more question. The final question. An aeroplane lands on a runway at a speed of 180 km per hour and is brought to a stop uniformly in 30 seconds, what distance does it cover on the runway before coming to rest? So now, I can infer from this question that our answer is in meter, but we were given kilometer per hour. That means we need to convert kilometer per hour to meter per second. That's first. Secondly, we were given seconds. They said brought to a stop. The car brought to a stop. The aeroplane brought to a stop. Meaning our final velocity will be what? Yes. 0. Yes. So we have been asked to find the distance it covered before coming to rest. So now let's write down our data. Our speed, in this case, don't forget, is always our velocity. That's our initial velocity. U is equals to 180 kilometers per hour. So I need to tell you how to convert kilometer per hour to meter per second before we advance with other data. So to convert kilometer per hour, what you do is, now let me write this for you. This is 180 kilometers per minute divided by hour. So all what you do is convert kilometer to meter, convert hour to second. So kilometer to meter, that's 1,000. 1,000 meter make 1 kilometer. So you will multiply the top by 1,000. What is the conversion of hour to seconds? 3,600 seconds make an hour. How did I get that? 60 seconds make 1 minute and 60 minutes make 1 hour. That means 60 times 60 will give you 3,600 seconds making an hour. So you will divide it by 3,600. So kilometer is up, I multiply it by 1,000. Kilo means 1,000. Hour, 3,600. So this will give me 180,000 divided by 3,600. So our answer is 50 meters per second. So you see, our initial velocity is 50 meters per second. So our other data, our V is 0 meters per second. Our time is 30 seconds. So that's all we were given in this question. So that means we have U, V, and T. Okay, and we have been asked to find distance. So that's all we are given in this question. So that means we have U, we have V, we have T, and we have S. So let's examine our formula. U, V, T, and S. U, V, T, no S, out. U, no V, out. U, V, no T, out. U, V, T, and S. Correct. So you see, the fourth equation of motion best suits our data. So let's substitute now. S is equals to U plus V close bracket T divided by 2. So our S is what we are looking for. Our U is 50 plus 0, which is V, divided by 2 multiplied by our time, which is 30. So 50 plus 0 is 50. 50 multiplied by 30 will give you 1,500 divided by 2, which will give you 750 meters. So our answer is what? C. You see it? As simple as that. Future rockstars. That's all you need to know. I need to also add that there are certain questions you may come across, as in JAMB Physics 2009 question 5, where they will give you certain data, then they will now ask you find the distance in the 5th second. What they mean by the 5th second, all you need to do is take time as 5, get your answer for distance, then take time as 4, get your answer, subtract it, that is your answer. So if they ask you find the distance in the 10th second, what you do, so use T as 10, get your answer for distance, and use see as 9, get your answer, then subtract it. So in the next class, we will be talking about projectile, a very important topic you can't afford to miss. So please do well to subscribe so that you can be notified when we drop new content. Also hit notification bell, share, like, and comment. I remain your host, Joshua, living to catch you another day. Shalom.